Now let's go back to our example. So you've seen this top part before. We have the results of our survey where you could see the mean, the standard deviation, and sample size for both groups. And then we have our null hypothesis and alternative hypothesis. And running this through statistical software, we get a calculated t of 3.38. And as I mentioned in the previous video, it doesn't matter. It's arbitrary how we get a positive or negative number because it depends on what we consider group 1 and group 2 in our equation. And so it doesn't matter because we're just going to look at the absolute value. And the rule would be that if the t is large, if 3.38 is large, then we're going to reject the null hypothesis. It means that there is a difference in the population. So at this point, you're like probably thinking, okay, great. But what would be considered large? Okay, well, we'll get to that because this is a series of videos, right? But before we get to that point, let's do a thought exercise. Let's pretend. On the left, let's pretend we live in a world where the null hypothesis is true. There's no difference between the young professionals and mature professionals. They'll just buy coffee at the same rate. And in this world where that's true, the null hypothesis, let's say we take 1,000 surveys. And for each survey, we get a t value and then we plot that. We record it. And then once we have those 1,000 values of t, we plot it. And this is what that would look like. And in this scenario, we have it to where the t values cluster around 0, whether it's positive or negative. 95% of the time, it's going to be within this curve right here. Now, in another world where the null hypothesis is not true, so we do 1,000 surveys, we calculate the t, we record it, and then plot it. This is what it would look like. So in this world, we have a lot of positive and negative values of t that are large, spread out away from 0. So in this scenario, what we're going to say is, okay, when t is small, let me create a text box here, we would make a bet that our t value is from this kind of distribution. So make this bet when the t value is small. And then we'll just do the opposite. If the t value is large, make this bet that it's in this type of distribution situation. So at this point, you're probably still thinking, okay, what is small? What is large? Well, I'll illustrate that in a second. First, let's get through a couple more points here. So we will consider a t value to be large when the calculated value only occurs, like if we would only get that value. Yeah, I should just read that, right. The calculated value for t is large if we would get a value that large less than 5% at the time if the null hypothesis is true. And because our t can be either positive or negative, we count both large negative and large positives. So to illustrate that, we look at this distribution where the null hypothesis is true, we say, okay, this is the cutoff. If the t value is to the left of this, if it's negative, or to the right, if it's negative, then it's large. We're going to reject it. So I'll just restate what I said here about what we do with the calculated t when it's large. So we reject the null hypothesis when the calculated value for t, the absolute value, is so large that we would get that value for t less than 5% of the time. So we're talking, if it's so big, less than 5% of the time it'll fall here or here. So it would be, let's put that here, 2.5% of the time under the curve, or let's just say 2.5% of the area under the curve. And I'll put an arrow, or I'll attempt to put an arrow. So we're talking down there. And then also down here. When the t value falls there, then we will say that that's a large value. So at this point, you're probably thinking, what is large, right? Well, there's a couple ways to determine when to reject the null hypothesis because it's so rare. We could look at a t-table to find the cutoff between large and small. And this is probably something that you did in your statistics courses, your other ones. Or we could look at the p-value on statistical software, which is what we're going to do in a later video. But let's do number one. So looking at a t-table, we have to consider the degrees of freedom and also our confidence value, or alpha. And looking at a t-table, this is the number that would say, okay, anything to the left or right of that would be a huge t value, a large t value. And it's 1.96 plus minus. So again, repeating the same idea down here, we reject the null hypothesis when the calculated value for t is rare. That is, it's so large that we would get that value less than 5% of the time if the null hypothesis were true. So 2 thought questions for you here. If we get a calculated value for t of 3.38, is it common or rare to get a value that large if the null hypothesis is true? Well, 3.38 would fall like way over here, something like that, right? So it's to the right of that cutoff for the degrees of freedom in our example, and also the alpha. So in this case, we would say it's rare. Okay, and then what about if it was minus 1.22? Well, that's going to fall somewhere here, right? And so it will be within the 95% right here. And so we would say, yeah, that's a pretty common value to fall right there if the null hypothesis were true. So we reject the null hypothesis when our calculated value of t would be rare if the null hypothesis were true. All right, in the next video, let's interpret our results.